Alright, well we're going to take a look at the basics of blobby rendering. And so what I'm going to do is I just want to create a single particle with the particle tool. Just one at the origin, move it up a little bit, and let me just go inside here and get that to be blobbies. So in the attribute editor for that particle, I'm just going to render attributes, setting the render type to blobby, which is a software render type, and I'm going to add attributes for that, which gives me radius and threshold. A radius is pretty obvious. It's just going to control the size of that individual particle. So let's make it a little bigger. And if we go into shaded mode, unfortunately, the software render types in Maya don't have a very nice hardware display. But I'm going to place this particle at the origin. And we'll see that with the one particle in the scene, that if I just do a render, what it renders like. And so basically blobby rendering allows you to take particles and render them so that they sort of render like geometry does with regular shaders. So I could assign Lambert, blend, Phong, and so forth onto this particle. And anything that you can do with shaders you can do onto their render types. And with blobbies, if you have a single particle, it looks like a sphere. But if you have a bunch of them, they'll blend together. And so that's the nature of blobbies. You could also refer to them as metaballs if you wanted to, meaning that it's just things that blend together as they approach each other. And so inside here, the first thing that you really need to be comfortable with if you're going to use blobbies is Hypershader, the multi-lister, as far as controlling the way this thing is going to render. And so let's just sort of take a look at the basics of that. And so this is something that you may be comfortable with already, but for those of you who aren't, it's pretty important to understand the relationship between sort of regular rendering and something like a blobby. So right now I just have a simple scene. I'm going to create a spotlight. And so I'm just going to make a sort of high key light over this particle. And let me take that spotlight and maybe increase its cone angle just a little bit. So I have a light that's above my particle. Turn on hardware shading. We can see it's going to have kind of a hard edge inside there. Maybe I'll increase the cone angle just a little bit more. And so now that I have this light inside here, I'm going to go back to the perspective view. And let me just go and get my resolution gate inside here so we can decide, okay, we're going to render this guy kind of like so. And now that I've decided this is where I'm going to stick my camera, I'm just going to select my camera and set a key on it just to save this view. So if I tumble around, I can just get back. So at this point, I can see I've got that, highlight over my particle. And at this point, if I go in and do another render, and we can see what we get. It doesn't look very nice yet, but I'm going to go in and just lower the size that we're rendering at down to 500. And right now I'm rendering with the Maya renderer. If I switch to Mental Ray and do a render, we'll see we're going to get the same thing. And so inside here, just going back to Maya, I'm going to go in and let's grab our light and make a couple changes. So first thing, I'm just going to turn on some decay. I'm going to increase the intensity of my light, and then just say tone that down a little bit. And I'm going to add a little penumbra to soften the edge of the light, and a little bit of drop off to also soften that light down a little bit. And so at this point, I'm also going to go to shadows and turn these on. When working with blobby particles, I can use depth map shadows. I can also use ray trace shadows. And if you're using Mental Ray, the ray trace shadows are going to work, but the depth map shadows with Mental Ray are not going to work. So ray trace shadows are what you want to use with Mental Ray, but with Maya's renderer you can use either. So let's say we take a look at depth map shadows. You should be aware that depth map shadows render a lot faster than ray trace shadows if you're trying to get soft shadows. If you want really crisp shadows, then ray trace shadows can actually be a better solution. But I'm going to go for softer shadows, so we're going to use depth map shadows. And I'm going to turn off autofocus and set my DMAP focus to be the same as my cone angle. This avoids flickering shadows when you render with spotlights. And so at this point, I'm also going to lower the resolution of the depth map so the shadow gets a little softer. Add a little DMAP filter also to soften the shadow. And at this point, if I go back to the render view window and do one more render, we can see that we now have something that looks a little bit nicer in the sense I've, again, added penumbra that softened the edge, added a little bit of drop-off, added a shadow that has a little bit of a soft edge, and we can see our high key. So inside here, we have a Lambert shader that by default is assigned to the particle, and so we can see there's no specularity on it. But you can see that the shadow is being cast from that single particle, so it pretty much looks like we have a sphere in there. And so at this point, as far as going in and designing the shader that's assigned to the particle, I could be using IPR to test things out, but IPR doesn't work with a particle. And so you'll see that if I go and do an IPR render right now, the particle doesn't draw. And so particles are not supported in IPR, unfortunately. You can see we get a little warning down here. And so for that reason, something that can be good to do when you're just sort of designing shaders for particle is I could just go in and make a sphere. Stick a sphere inside here that has the same radius as my particle, pretty much. And then use that so that with IPR I can go in and design the shader on the sphere and then apply the sphere to the particle. So that's just a sort of a faster way to approach things. I could always go and take that sphere and just stick it on a display layer. So I could make, for example, one display layer that has the particle object on it and another display layer that has the sphere on it. So I can simply sort of swap which one I'm looking at and which one I'm rendering. So the first one, I'll just call that my particle. And the next one, I'll just go and call that my sphere. That's my sphere layer. So anyway, at this point, also what I want to do is jump out to the render view window. I've got the render that I did before, but I'm going to go inside here and let's actually go rewind, do a render, and at this point, that's the render that I want to keep. So I'm going to get rid of this one. And let's save this image. So this is kind of our start point. So we can sort of compare sort of where we started with where we end up. So the first thing I want to do inside here is let's just go and jump out to Hypershade or the multilister. It doesn't matter. I tend to use the multilister a lot just out of habit. But just because I've been using Maya for a long time. Before Maya, there was Power Animator and Multilister. And Multilister, I feel, updates a little bit faster, and so that's why I use it. When I'm doing a lot of networking, shading, that's when I use Hypershade. But at this point, I'm going to go and make a blend shader, grab the particle, and assign that shader to it. So that if I now go in and do a render, we'll be able to see that we clearly have a blend shader now assigned to our particle. So even though I did make that sphere earlier, you can see that's not what we're rendering. We are rendering the particle. So regular shaders get assigned to particles when they're blobbies, just like they get assigned to geometry. So now if I wanted to go and get different looks with this particle, it really would just be a matter of going in and playing with my shader. And so let's say we want to go in, for example, and create a chrome shader. What would we do? Because maybe we wanted our particles to render as if they were mercury. For something like that, I basically would need to go to the blend shader that's assigned to it, make the color dark, make the specular color and the reflectivity high, maybe lower the eccentricity to make it a little shinier, and this is how you would approach something like chrome, a very dark color with a high specular color. And so obviously if I'm doing something like chrome though, I would need reflections, which would mean I'd have to go into my render globals and turn ray tracing on. And so if I now go in and do a render, you'll see that we now have a chrome sphere inside here. So what I'm going to do though is I'm just going to slap a texture on the floor, on the ground inside here. Let me just make another shader, just so that there's something that's a little bit more interesting to reflect. And so I'm going to make another blend shader that's maybe not so shiny, maybe not really reflective, or maybe that's actually for starters. Let's make some reflectivity on that. And let me go in and grab a file texture. I'm going to make it reflective just so you can see the particles can get reflected in things. And so as far as grabbing a texture real quick, let me just go and grab something. So let's just go out here, Maya, projects, particles is in here somewhere, and let's see, what do we want to grab? Doesn't really matter. Let's say I go and grab some generic ground texture. Let's say maybe some concrete. See what that looks like. That's fine. And so if I look out here, I can see that that's now on the ground. I'm just going to repeat it a couple times. So let me repeat that a couple times in U and V. And also I'm going to turn off the blur on my texture. Just the filter defaults to 1, which softens your textures. I'm lowering it down to 0.1. And then on my shader for the ground, let's just go in just to make it a little bit more interesting. I'll just go in and take that and also assign it as a bump map. And for the bump, I'll lower the depth down, 0.1. And then maybe I'll also throw a specular map in there. Maybe I'll just take that texture, copy it, and take the copy and put that on specular color, which by default is going to be a little bit bright, but I'll just remap it. And so remapping a specular map is handy so that you can go in and change the contrast. So you can see I could go in, for example, now and modify the contrast. So you can see how now that's something that as a specular map is going to create a little bit more of a dynamic effect on there. So this is something that with the lighting in my scene I'm not going to see a huge difference, but I'm just doing that just so you can sort of see general things that I tend to do a lot. But anyway, we have a texture on the floor now. And so at this point, let's just go and do another render. And so we'll be able to see that that definitely is being reflected into our sphere if we look inside here. And then also with that, if I go in and decide to see the sphere reflecting in the ground, maybe the ground is a very shiny ground, for example, so that if I go to the ground, we did turn on reflectivity. You can see the reflectivity is relatively high on the sphere. Maybe we'll make it a little bit shinier. Maybe we'll increase the specular color just to make it a little bit brighter in the specularity. But when I render, what you're going to see is we don't seem to be getting a reflection of the particle in the ground. If this was geometry, we would because of default attributes, but with particles, something to be aware of is that if you select the particle object, you'll notice that on its shape node, under render stats, you'll know that most shape nodes for renderable objects have a render stats folder, and so do particles. It's right there. But you'll see that it's got visible and reflections and visible and refractions unchecked. So if I grab something like a piece of geometry and go to the render stats, you'll see those are on by default with surfaces, but not with particles. And so I would need to go and turn on visible and reflections if I want to see a reflection of the particle in the ground. So that's one thing to be aware of. You'll see by default it casts shadows and receives shadows. Primary visibility is on, meaning that it renders. So for example, if I turn that off, I'd get the shadow, but I wouldn't get the particle. And so just to show that to you, you'll see that if I render, there's a shadow, but no particle. And so that's something that's useful when you're rendering a shadow pass, which is something that we'd end up having to put a use background shader on the ground. But going back to our particle, turn on primary visibility, visible and reflections. We can turn on visible and refractions as well, just if that's something we think we may use. And at this point now, let's go in and do one more render. And so inside here, looking at our scene, now it doesn't necessarily look like we're getting a reflection of the particle in the ground, but what I'm going to do is let's just sort of pull back a little bit, just because the angle that we're seeing things at is playing with us a little bit. And so at this point, if I look inside my scene, I think that part of my problem is that the way my particle is set up as far as rendering is that even though my ground is reflective, we're just not seeing it. What I'm going to do is let's take our particle, let's go to its blend shader, and let's go and let's say add a little bit of incandescence to it. I'm going to go to the incandescence. I'm going to grab a solid texture such as marble, for example, maybe with a bright vein color. Grab the 3D placement node and scale that up a little bit. And let's do a render. And now you can definitely see that we are getting that reflection in the floor, in the ground down there. And so if we look inside here, you can see we definitely are getting reflectivity. And so it's just something that because of the texture we have in the ground, it's just a little bit subtle. So I'm going to go to the NURBS plane, go to its shader. Let's just sort of exaggerate things a little bit. Let's get the specular color to be a little bit brighter inside here. And let's render again. And so we can definitely see in our scene right now that we are getting our reflectivity in the ground. It is a little bit broken up just because I do have that bump map and the specular map that's in the ground texture. If I didn't have those, it would be a little bit more clear of a mirror reflection. if I went to the ground and decided to assign the same shader to the ground, or a derivative version of that, for example, if I went to the blend shader and for a second just decided to make the color really dark, and went to the specular color and made that really, really bright, we would be able to see a clear reflection, although the bump map is still inside here. And so there's a reflection. So if I went to my particle and set on its shape node visible in reflections and refractions to off, which again were the default settings, we would see no reflection. And so at this point, I'm just sort of trying to illustrate some of the basics, and so some of this might be very, very fundamental to people who already know some of these things, but these are things that are not necessarily obvious by default. And so going back inside here, let's go back to our ground plane, and let's go and decide that we want to reassign those textures. And so I'm going to go in and, let's say, reassign that color map and that specular map to our shader. And so I'm just going and undoing all the things that I did, so that now my ground is going to be reflective. But now I'm not really going to focus on the reflectivity on the ground anymore, so I'm just going to turn that off, make it a little bit softer. I'm going to go to the specular color and darken that down a little bit, so that now we can focus more on our particle. And so you'll notice, for example, with the particle, that I assigned that incandescent shader to it. And so something like that you can see is working. And so with our blend shader, basically we can go in and texture any of the attributes, and it will work correctly with the particle. But you do want to focus on 3D textures, for example, for something like the incandescence, so that it goes through the particle. The particle doesn't have UV space the way the geometry does, and because of that, if I went in and assigned something to the particle that wasn't a 3D texture, we get a very flat display on that particle. And so if I went inside here, for example, and went to the particle, and let's say we disconnected that incandescence map, but instead of the incandescence map being a solid marble, let's say I went in and grabbed something like a normal flat checker pattern. If we go in and assign that and do a render, you'll see that it does get mapped, and so you'll see that it is mapping itself around that surface, but you'll notice that there is a pole right there, and you don't really have any control over where that pole is or how the texture maps onto the surface. So if you're using a tileable texture, you can get away with it. Just be aware that you're going to not be able to sort of control the UV space. And so let's go out here and take a look at some other things we might want to be able to do. So we've seen that we could go and create a chrome look, for example. And so if we go out here, let me just go and undo to get rid of that checker pattern. And so if we go in and get rid of this marble as well, delete highlighted. So we're back to just having our chrome look. The next thing we want to do is be like, okay, well, chrome is pretty easy on our particle. What if we wanted to go and get something of a different look? Maybe we want to go something that's more of a liquid look. And so for something like that, whether it's a liquid that's a clear liquid like water, or maybe we want to make these particles look more like sort of gemstones or something like that. Well, that's just a matter, again, of just knowing how to tweak your shader. So if I go out to my blend shader, and I wanted to create something that looked more like a gem, for example, what I would end up needing to do is I still would use a very dark color, but I would go and put in transparency, and then I could color the transparency. So if I go inside here and, for example, create a blue transparency on my particle, that's how I would approach something that would be like a bluish gem. Then inside here, I would still leave my specular color at white, meaning that the specular color on a gem is the color of the light source. So you want to leave your specular color at white. But I'm going to make it pretty shiny, very specular, relatively reflective. And then inside here, if I go in, I'll also want to go to the ray trace options. Now that this material is transparent and we can see through it, we may be interested in having some refractions, which works with particles as well. So you can refract the light that's going through a particle or the objects that you see through a particle. The default refractive index inside here we can see is 1. Now we're not going to go over all of these attributes because this is sort of fundamental hypershade material settings. But just so you can see that your knowledge of this is important, let's go and put our refractive index maybe to something like 1.05, because a refractive index of 1, the light's not going to bend. So let's get the light to bend a little bit as we look through that material. Also in our render globals, ray tracing is on. We can see refractions are set to 6 and reflections are set to 1. And so our light is going to be bounced once as far as reflections, and we'll be able to see through 6 surfaces in order, or 6 sides, in order to be able to see through a refractive object. But be aware on your shader, in your ray trace options, you also have control over the reflection limit and refraction limit in there. And this is what's going to be, your render globals are the most important, but if your render globals are set to 6 and this is set to 3, it's going to do 3. While if this is set to 6 and your render globals is set to 3, you'll get 3. Render globals is dominating what's happening inside here, but this is still very important. So at this point, with those changes made, if we go back out to our render view window and save our chrome material, so we can see we have inside here our original start point with Lambert's, then moving on to a ray trace reflective chrome. Now if I go and do another render, we're going to get a different look. And so inside here, you can see that we are seeing that blue inside that surface, but you'll notice that we are also seeing that we still have this shading on the top here, because we did have some shading set in the blend shader. But if we go and take, for example, a higher angle on our particle, let me just go and center my view over that, and then come down on it, we'll be able to start to see some of that blue coming through based on the transparency. And so at this point, this is sort of where you're going to start tweaking your shader. Now when you're tweaking things like refraction, it would be nice to be able to use IPR, but ray tracing doesn't work with IPR. So I am going to need to go inside here and basically modify my shader and make changes. So let's say we go to our shader and decide that we also on the color want to just give it a little bit of a bluish hue as well, but still keep that dark and keep the transparency light and blue. We're going to be able to see how we are changing that light that's bending inside here. And so at this point, we have a very, very dark scene, and so it's just going to be a matter of sort of finding an angle at which we can sort of use as a good testing point for testing what we're doing. So now you can see that we're seeing that shadow inside there that's bending and some of the blue coming through. But another thing to point out is notice that as we are designing this and getting this appearance inside here, I'm going to also go to my light source. Let's make our light a little bit brighter. Let's jump it out to about 17, just so our image has some more contrast in it. So it's a little bit easier to see the results of what we're getting. We can see if you look at the shadow edge inside there that the light is definitely bending. And so at this point, if I go in, I'm going to go also to my shader. I'm going to make it a little bit shinier. So let's say I'm going to go to the specular shading and lower that down a little bit. And then inside here, let's say we decide to change our refractive index again. Right now it's at 1.1. Let's put it to 1.2. Let's go out here and save the image and re-render. And so you can see we're definitely getting a very different look inside here, where we're getting a little bit more dramatic of a bend on the edges. And so now we can see, if we compare, how changing the refractive index is having a big effect on the particle. But be aware also that we're getting a black shadow. But if this was something that was blue, you would expect the light that goes through that to become blue and cast a bluish shadow. You're not going to be able to do that with depth map shadows. And so that's something that you're going to need to go to your light. And if you want the transparent color, the color in the transparency of an object to affect shadows, you do need to ray trace your shadows. So let's jump to ray trace shadows for a second. We are already ray tracing, and let's take a look at that. And now you can see we get a much more dramatic change in the shading inside here. Notice that instead of getting this very thick black shadow inside there, we're now getting something that is creating a much more accurate look inside our material. And so we just went from this to this. So we're getting a very, very hard edge though, because it's ray traced with default settings. And so I could go inside here and increase my light radius to create a softer light, meaning that this is the size of your light source, and the larger your light, the softer the shadows. But the issue to be aware of is this does slow down rendering quite a bit, meaning using soft shadows with ray tracing. So something that's also a good thing to do if you decide you need to ray trace your shadows is to render them separately with harder edges and then blur them in post. Because creating the blur that I have on my shadow right here while taking a while to render with Maya would be a very fast thing to do with a blur node in a compositing package. But at this point, since we only have one particle, our render time isn't too bad. And so now you can see that we've now taken this particle, and just by going and tweaking some basic shader settings on it, changing some specularity, maybe going inside here and let's play with the refractive index. Let's go back to 1.1 again. You can see that we're getting a pretty nice look on our particle as far as getting an interesting shaded appearance. And really everything we're doing is all about our knowledge of shaders. So it's really not very much about our knowledge of particles. So you really want to spend a lot of time brushing up on your knowledge of shaders, your knowledge of materials, all of the attributes inside here, so that you can get better results out of your blobby particles. And so at this point you can see that, very, very big difference inside there. So starting with the boring Lambert sphere, we're going through basic chrome and then into, a more interesting shaded appearance. So obviously you can very easily go and design different shaders like this and save them out to create a quick shader library for different looks you're going for with your particles. But if we wanted to look at some other examples of things we could do with this, right now we have this sort of bluish gem type look, but let's say we want something different. Well, I'm going to go inside here, and let's say we go back to this camera view and decide we want to do something like we were doing before with that incandescence. Well, I'm going to go inside here, and let's say we decide that we want to create a blobby effect, but we want it to look not necessarily like this hard surface. Maybe we want to get some sort of softer effect using blobbies. Well, that is totally possible. Maybe I'll keep this shader around, but let's create a new one. So I'm going to go and create another blend shader that I'm going to assign to my particle. Just grab that, assign. And for this one, what we're going to do is, instead of focusing on a blend material, maybe we'll start with blend and then sort of tweak it a little bit. And then also inside here, let's use our sphere, our geometry, so that we can test this out a lot faster using IPR. So I'm going to go and assign the same blend that I have on my particle to that sphere, do an IPR render, and then once this loads in, we don't get our shadow because of the fact that IPR does not support ray trace shadows. So IPR, when it's done, is going to tell us to turn off our shadows, or turn off ray tracing. And so at this point I could just go out here and say ray tracing off, and I could go in and marquee drag that region. So now, going to my sphere, as far as designing the shader, just to do something that looks very, very different than what we did before, I'm going to go in and maybe do something where my color goes down, and so maybe I'll put my color to black. Also inside here, maybe I'll decide to turn off my specularity. I could put the specular color to black, and that's just going to give me a Lambert shader. So now I have black color, black specular color, but then I'm going to go to my incandescence. And let's say we go and grab again one of those 3D textures, like a 3D marble. Then inside here, let's go and maybe just use our vein color inside here. Maybe instead of default red, maybe we'll go to some bluish color. And now that we have this, we can see we'd have to rely on our placement node. So I can use the placement node to change the look of what I'm getting. So I'm just going to scale it up a little bit so I get a nicer result with a little bit more variation inside there. And so you can see that I can go and scale this. Obviously I can animate this. I can go back to my marble node and maybe modify diffusion. So you can see that obviously using IPR is something that's rather valuable that you're not going to really be able to do if you were just relying on re-render with a particle, because that's going to take a while. So at this point I'm just going in and changing things to decide the look that I'm going for, maybe to get something that looks a little bit more natural and organic. And then once I have that look, I could go back to my shader and decide, okay, well now what I'm going to do is I'm trying to create a look of something that isn't like this hard object. Maybe I want to go in now and add a little bit of glow. Well, if I go and add a little bit of glow inside here, a little post-process glow, obviously it's going to go and glow that shader out. Let's go and now marquee drag a larger region. And so let's just go and say, okay, fine, close the IPR file and stop tuning just because I grabbed a larger region. And what I'm going to do is redo the IPR. Let this load in. And then glow is a post-process, so first it's going to render that object in, and then it's going to add the glow afterwards. Give this a second. So we can see this glow that's on the entire sphere. Well, now what I'm going to want to do is you'll notice also I'm not getting our shadow. Well, that's fine. Maybe what I'm doing is now I'm trying to say that maybe this is some sort of particle that's incandescent, that's illuminating, that's glowing. So now that I've added that glow, maybe I'm also going to turn on hide source. Hide source is really cool because what this is going to allow me to do is basically render the glow, but not render the geometry. Now in this case, you're going to see that it is going to force me to redo the IPR. So let's go and say, fine, redo the IPR. Because when you make geometry changes, IPR doesn't see that. So now you'll see no geometry is drawing, but then when it's finished rendering the scene, it'll render just the glow effect. And this is a cool thing that you can do with blobbies to get really nice results. Because then basically I can go in and design the look of sort of this sort of like plasma look with my particle. And so now I can go inside here with that soft glow, let that draw itself in, and then maybe increase the glow intensity a little bit, so that now I'm getting this sort of stronger effect. Now something like this maybe is supposed to be illuminating my scene. Now particles don't illuminate a scene by default, so I'd have to go and make a light source that simulates that effect of that particle on the scene. And so maybe I'd go in my scene and create a little point light inside here. And let's go and grab that point light, move it inside here, stop the IPR file, also give it maybe that same color with a little bit of linear decay, maybe add a little bit of intensity onto that, go out here, and then render that. And so now I'm going to have this illumination on the ground that is explained because it's coming from this particle object. So at this point, we're getting an interesting look. My light's maybe a little brighter than I want it to be, so I'll lower that down a little bit. But then also be aware that when you're designing things like glow, that you also can use the shader glow node that you have in Hypershader, the multilister. And so there's that result. But if I go out here, go to the shader glow node, which is what controls the way glow looks on any objects, I'm going to go in and, let's say, increase the threshold a little bit. If I increase the threshold on your shader glow node, all that means is that it's going to glow more in regions that are brighter, so it's going to threshold the glow on that surface. So you're not going to get such an even glow all over the place. So you can see that threshold was a little bit high. So I'm just lowering it down a little bit. And so once this sort of pops in, I'll be able to see like, okay, well, I'm getting glow, but now look. Now I'm getting this sort of cool glow where I've taken something that was a sphere and converted it into this sort of three-dimensional volumetric sort of incandescent result, which would be cool for making sort of a plasma look. Again, for something like that, the light is still too bright, so I'm just dimming that down. And so at this point, this is something that is a completely different look than what we did before. And so if we go inside here, you can see we went from, that to something that, is still very, very useful, but completely different. And so inside here, granted we are rendering all this stuff on that sphere, but if I just go and switch to the particle and render, you're going to see that the work that we did on the sphere is going to apply to the particle as well. And so there might be subtle changes because sort of the UV space on a particle is a little bit different. And so basically I would need to go in and make a couple changes maybe to the glow intensity. But you can see that it allowed me to get very, very close. So it got me like 90% of the way there. And at this point, maybe I'll just lower the glow intensity down a little bit, and maybe I'd want to change the threshold a little bit on the shader glow node. But again, using that sphere for previewing was a little bit faster. So now you can see we have it pretty much looking the same just by lowering the glow intensity. So the next thing to be aware of that's really, really handy with blobbies, though, is using facing ratio, which is also something you might be familiar with, meaning that right now I have this look where I have this even glow all the way through the particle, but maybe you want to do something which is more like a flame effect using blobbies. For something like that, let's see if I can go and find an example of that real quick out here. Let's go and see if I can. And so let's see, yeah, like something like this, for example. Once I get that thing to open, which for some reason is taking a while, which is kind of bizarre. There it is. All right. So inside here, this is an example of blobby particles rendering with a shader that's like a candle flame shader. And so if I stop this and we take a look, you can see that it's transparent at the center, more incandescent on the edges, bluer at the base, and then orange down towards the tip. And so for something like this, I'm designing a shader where my blobby particles are born with a large radius, die with a small radius. They're born with a bluish color and go into an orange color. But then the shader on them is only rendering the glow. And then the shader on them also has facing ratio, meaning that it's more transparent in the edges or in the center, and also more incandescent on the edges. And so something like that is really, if you can make a piece of geometry render to look like that, then you can get blobbies to render to look like that. Another example of something like that is this movie, where basically it's sort of like a simple little burst effect, where I'm using the exact same idea of using facing ratio. And so inside here, this effect is very simple, where basically we have like a little optical effect that goes into a particle effect. But these particles that are expanding are blobbies as well. And so you can see that basically blobby is rendering with facing ratio. And so you can see inside here the look that we're getting based on facing ratio. So if you don't know what I'm talking about when I say facing ratio, basically it's just a matter of going in and let's design a quick shader that's an example of that. And so what I'm going to do is let's go and make another shader that's new. Let's say create another new blend shader. And inside here I want to do something where maybe I want to be able to get on this piece of geometry, if I do a regular render of it, we're going to get that. But since we're no longer dealing with that transparent refractive object, I'm going to go to our light and switch back to depth map shadows. So let's go inside here, turn on use depth map shadows. I'm going to take that point light in the scene and turn that off for a second, so that now if I render, I'm back to just having a sphere with a shadow on the ground. And what I want to do is, let's say I just want to get a red ring around the contour, around the edge, using incandescence. For something like that, you'd end up needing to use facing ratio. And so let me just show you the basics of that. I'm going to go inside here, and with my blend shader, this is a time where I'm going to want to use hypershade. And in hypershade, I'm going to take the material that we assigned onto our particle, and for it I'm going to go and create a couple things. First, I'm going to create a utility node, and the utility node that I'm going to create is called sampler info. And the sampler info utility node is the node that has the facing ratio attribute. You can see right there, that's what we want. And this returns a value of 0 to 1 based on the angle of the surface to the camera. And so this, again, I'm showing a lot of things that might be review for people, because again, we're talking about blobbies, but we're really talking about shader stuff. I'm going to go and create a ramp texture. So let's go inside here, and there's a ramp. And the reason I'm creating the ramp is basically what I want to do is say that based on the angle of the camera's view to the surface, we want to choose a different position in the ramp. And so to do that, basically we just take the facing ratio of the sampler info node. Let's just do this in the connection editor. So the sampler info node is the output. Grab its facing ratio and drive the ramp's v coordinate, which is the vertical direction by default in the ramp. And so this returns, as we know, a value of 0 to 1. So if the value is 0, we'll be at the bottom of the ramp, and if the value is 1, we'll be at the top of the ramp. Then I just take my ramp and connect its out color, in this case to incandescence. And you immediately can see that this works and that it previews it in hypershade for you. So that you can see that if we look at our ramp, if the value is 0, we're at the edge. If the value is 1, we're at the center. So obviously facing ratio returns a value of 0 when the surface is pointing away from the camera, and returns a value of 1 when the surface is pointing to the camera. And so inside here, to make that red ring, I would just go in here and do this. Let's say go to a smooth interpolation just to make it a little softer. Maybe bring this down a little bit. And if we go back out here and do an IPR render, you'll see that this all works. So now I have this sort of Lambert shader, or a blend shader rather, that is got an incandescent ring on the outside of it. And what we just did is something that obviously can be used for different looks, meaning I could go inside here, for example, and get rid of the surface shading on the interior and just render that exterior ring. Or I could decide and render just the glow effect like we did before. But everything we just did will work with the particles. So just so we can see, if I go to my shader though, let's grab the sphere. Let's go to the blend shader, and maybe we'll go in and say specular color off. Let's go and turn the color off. So now we just get that incandescence ring, and now we can add a little bit of glow intensity, and you can see now we're getting that glowing ring. And if I decided inside here that I wanted to say hide source and just render the geometry, I could choose to do that as well. And so inside here now, if I render, we don't see the geometry, but we're just going to get this red ring on the periphery. And so inside here we're not getting a very solid ring because our glow threshold was raised a little bit, because we did that earlier. Go to the shader glow, maybe lower the threshold down to a lower value, and then also maybe go in and swap to our particle, which is still assigned the same shader inside here. So let's go to our particle and say, well, you're supposed to get this blend shader, the one that has that incandescence map on it. And then with that blend shader, maybe I'll go in, since we have that, and maybe I don't want this to cast shadows anymore, because maybe this is supposed to be incandescent. So I would turn off cast shadows, go to that point light we have inside here, and then this time maybe make it reddish and turn it back on and render. And so now we're going to have this sort of little bit of a pinkish illumination on the ground, and then we're going to get this particle rendering as a ring. So that's just a single particle. So you can imagine that if you have a whole bunch of particles inside here with this shader on them where they're blobbies and all blending together, you're going to get a pretty interesting look. So going in and combining some of these different looks inside here, meaning, for example, combining the idea of facing ratio with a shader like this, you could go in and get this kind of look, but perhaps only in the center to soften the edge, or maybe just on the edges where it's completely transparent in the middle. So this whole process is something that you definitely will want to experiment with quite a bit, because you'll be able to get a lot of different results, meaning that, for example, inside here I have this solid ring. If I wanted this ring to have sort of fractalized look to it, I can go and combine a bunch of different textures together, meaning that I could have the facing ratio be driving the color gain of this marble texture, so that I could go and have the marble texture be brighter in the center but be darker on the edge. So it goes from this blue color down to black, meaning no incandescence on the sides. And so inside here, basically we've now talked about the basics of blobby rendering on a single particle. And so the next thing that we would want to do is take these principles and apply them to multiple particles. And so again, we've now created, a couple shaders inside here. We have the one which is the red ring. We have the one that creates the sort of bluish glow inside here, so that if we go and render that one, we're going to end up with that bluish glow, but now creating this reddish light. So now we have that. And then inside here, again, we're getting it everywhere because we didn't modify the threshold. If we did want to take a look at using facing ratio in connection with this, it'd be a matter of going back to our sphere so that we can test it a lot faster using IPR. So I'd have to go and now assign, let's say, this shader back to the sphere. Go and do an IPR render, but again, just to make life easier, lower the resolution that we're rendering at so that everything happens a little faster. And so once this pops in, since we're back on the sphere, we're getting a shadow because the sphere still has cast shadows turned on. So there's that look. So if I grab that and I go to my sphere and we go to its shader and I go to the incandescence map on it, right now you can see for this it's going all the way through, but there is an attribute in here called color gain, where if I lower the color gain, you can see I'm reducing the glow. So if I put the color gain to black, we get no incandescence. Put it to white, we do get incandescence. So obviously if color gain was controlled by our facing ratio, we would be able to control how much of this we get in the center versus what we get on the edges, or vice versa. And so if I wanted to get this effect, but more on the edges and less in the center, it would just be a matter of controlling color gain. And so if we wanted to take a look at that, we really would just need to go and say, okay, well, we do the same thing. We'd go out to Hypershade, we'd go and grab the shader that we're working with, which is going to be blend 3, just to double check that it is blend 3. Just grab that in here. And then with blend 3, if I go inside here and graph the network, I can see there's that marble. But now I would go to the Create tab. Again, we would need a sampler info utility. And we would also need a ramp. So I'm going to go and create a regular 2D ramp. And then once I have that, again inside here, the sampler info node, if I right click on it, facing ratio on that node is going to the ramp's V coordinate. And then the ramp, we know that we want it to just be black to white, like so. And then once we have that set up here, we want it to drive something on the marble. And so we already realized we wanted to control the color gain. So I would take the ramp's out color and connect that to the ramp's, or the marble's, color gain. And so if I go and connect them that way, if we go out here and then go back to IPR, we have now modified the glow effect that we're getting inside here. And so let's just go to our ramp, just make it a little bit more extreme, so that we can see the different results that we're getting as we go in and change that ramp. And so in order to preview this a little bit faster, what I'm also going to do, because very often I'll just go and change things just for the sake of making things preview faster, is I could go and turn off the glow and turn off hide source, so that we're literally just rendering that geometry. I can also go to my light and turn off the shadow, because the more things you turn off when you're using IPR, the faster things are going to behave. And so at this point, inside here on my geometry, I can see that that's what's happening as far as it's rendering. And so if I go inside here, now I can see, okay, well, there's something funky about that. And so now I would want to go into Hypershade so I can tweak this a little bit faster. So I'd go inside here and grab my shader, graph its network so I can see what's going on. So for example, if I disconnect that, this is where we are. But if I went inside here, for example, and decided, okay, well, we can see that when I connect the ramp to the marble, and our ramp again is looking like this, again taking the out color and connecting that to the color gain, that we're getting this sort of strange result. It's sort of mapping it based on the UV space, not based on the normals of the surface. So, but if we went inside here and disconnected the marble from the incandescence and connected the out color of the ramp directly to incandescence, you'll see that it works, that it is based on the facing ratio. And so for something like this, it's like, okay, well, it works when it's connected directly to the shader, but not when it's connected through the marble. And so inside here, basically I could go in and be like, okay, well, on my ramp that I have inside here, I know that if I want to control color, I could go in and take this and give it that bluish color, for example, and now I'm getting more incandescence in the center of this. Maybe switch to a smoother color. So I'm getting incandescence in the center. If I also want to get transparency on the edge as well on the surface, maybe if I really want it to be soft, then I could go in and add transparency to this as well based on facing ratio. Or I could just make the entire shader transparent. So if I go in and up the transparency on this, I have something that's completely transparent but only incandescent. So if we redo the IPR, you're going to see that we're going to get something that's not going to have that black rim. We're only looking at the incandescence on this right now. And just wait for this to draw in. And then once that's done, we can see that now that incandescence on that ramp is really, really bright. So if I darken that down, you can see that we can go in and control the brightness that we're getting on based on that incandescence. But inside here, let's say I went in and decided, okay, well, my ramp, does anything control the brightness? Well, on my ramp, you'll see that we also have color balance. If I lower the color gain, that does work as a multiplier. So what if I went in and took my marble, let's go and take our textures inside here, And instead of going and connecting the ramp to the marble to the shader, what if I go in and just plug the marble out color into the ramp's color gain? Now you can see it's working. Meaning now I have the combination of my marble texture with the facing ratio ramp working on my shader. So that I can now go inside here, go to my ramp, and control my incandescence of that marble. So I can get just more of that marble in the center, for example, and have a really soft edge on particle rendering. And so also I could go in and invert that and have it more on the edge. So that now, let's say I go in from black to that color, so that it still has a soft edge, right? Where at this point at the bottom where the facing ratio is 0, it's soft. I can go and bring this in a little bit, move that up, bring this up towards the top, and now you can see this sort of interesting shaded look that I'm creating on this individual particle, but it has this nice sort of noisy edge to it using that texture. And so at this point, we've now definitely created something that is an interesting and unique look. The color inside here, though, be aware, is actually coming from the ramp. So if I go to my ramp and go to this color, we could go and maybe give it an orangey color. Instead of that, let's say we go in a little bit more saturated towards orange. And maybe a little bit more. But either way, you can see that all of this stuff is completely working. Maybe we're going to get it to be a little bit brighter. So I can raise the brightness on that a little bit. And so the nice thing is that this was all previewed really, really fast to get to the point that I wanted to get to. And then now I could go and be like, all right, well, now that I've gotten all that stuff done, we could go back and do our final sort of test on going back to saying we just want to render glow maybe, or add a little bit glow into this shader. And so as I add some glow onto the shader, we can see that that glow is coming in based on the threshold that we currently have. I could say hide source. Maybe add a little bit more glow inside there. And so now you can see we've gotten something that is, a very different look for the particle rendering that we would go in and do. And so also I can go out to my shader glow node, which is inside here, and control my threshold. If I put a threshold to 0, raise the threshold so it's more focused in specific regions. I could go and turn off halo so I just get glow so it doesn't bleed out so much. I could go inside here, for example, with my glow and control the spread if I wanted to spread out even further or not quite so far. So all of these attributes inside here, which is a whole other discussion, can be used to design the look of that glow. And then now inside here, let's say we decide, okay, well, maybe we want our threshold to be a little lower, and then maybe just make it more dramatic on our shader. We'll go in and up that a little bit more. So now we have that look. But with that all done, I could go in and say, well, what does this all look like on the particle? And so if I go and get the particle visible inside here, there it is. And let's go and do a render of the particle. And again, it's going to be pretty close. You can see it's a little bit stronger now on that particle. Maybe I'll go to that point light and get its color to be more along the lines of the color we're seeing there. And let's go and maybe get that to be a little bit brighter. And now we have this. So hopefully this has sort of shown you, and you can see there's like a lot of interesting detail inside there on the edges with that individual particle. And so, we've gone through some different looks, just some fundamental shader stuff. So, again, this shader that I just made, I could apply to a car and get a car that would render like that. Just sort of neat shader stuff, but useful for understanding what effects you can get with blobby particles. And so the next thing we're going to do is, the next thing to do is discuss applying this to not just a single particle, but to multiple particles, so we can see what attributes like threshold on a particle does, as well as some other neat things with blobbies. But that's sort of the fundamental start point that you need to understand, is the fact that you really need to be comfortable with shaders and materials before you start trying to render blobbies effectively. And so that sort of concludes the sort of basic introduction to this stuff, and there you go.